In section 12.5, we talk about problem solving with the normal distribution. So we have seen that male heights in North America are approximately normally distributed with a mean of 70 inches and a standard deviation of 4 inches. Suppose we are interested in the percentage of men with heights below 80 inches. And so we can find the z-score. That's by taking the data item of 80, subtracting the mean with 70, and then dividing by 4, which was the standard deviation. And we get 2.5. Now, because the z-score is not an integer, the 68, 95, 99.7 rule is not helpful in finding the percentage of data items that fall below 2.5 standard deviations of the mean. And so the table below gives a percentile interpretation for z-scores, and this will be given on your test. And so we would go and look for the 2.5 z-score on the chart, and that gives us 99.38%. And so what that means is that 99.38% of North American men have heights that are less than 80 inches, or z equals 2.5. In a normal distribution, the mean, median, and mode all have a corresponding z-score of 0. The table shows that the percentile for a z-score of 0 is 50. Thus, 50% of the data items in a normal distribution are less than the mean, median, and mode. Consequently, 50% of the data items are greater than or equal to the mean, median, and mode. So you have 50% of the data items below and 50% of the data items above. The table above can be used to find the percentage of data items that are less than any data item in a normal distribution. Begin by converting the data item to a z-score. Then use the table to find the percentile for the z-score. This percentile is the percentage of data items that are less than the data item in question. So according to the Department of Health and Education, cholesterol levels are normally distributed. For men between 18 and 24 years, the mean is 178.1. This is measured in milligrams per 100 milliliters, and the standard deviation is 40.7. What percentage of men in this age range have a cholesterol level less than 239.15? So we need to find the z-score for 239.15. So we take 239.15 and we subtract the mean, which was 178.1, and then we're going to divide by the standard deviation, which is 40.7. So on top we get 61.05 divided by 40.7, or we get 1.5. And so going up to the table, you'll look for 1.5, and this gives us that this is 93.32%. And so what this means is 93.32% of men between 18 and 24 have a cholesterol level less than 239.15. The normal distribution accounts for all data items, meaning 100% of the scores. This means that the table can also be used to find the percentage of data items that are greater than any data item in a normal distribution. You're going to use the percentile in the table to determine the percentage of data items less than the data item in question, and then you'll subtract that percentage from 100% to find the percentage of data items greater than the item in question. So all you're going to do is you find the percentage just like what we did in the first example, but if you want to find greater than the data item, you just subtract the percentage you found from 100. So the lengths of pregnancies of women are normally distributed with a mean of 266 days and a standard deviation of 16 days. What percentage of children are born for pregnancies lasting more than 274 days? So the more than is important, but first we need to find the z-score of 274. And so we take 274 and we subtract the mean, which is 266. And then we want to divide by the standard deviation, which is 16. Well, this gives me 8 over 16, which is 0.5. And if I go to the table, that corresponds to 69.15%. And this is below. But we don't want below, we want above. So we need to subtract 69.15 from 100. And that gives me 30.85%. So this means that 30.85% of children are born from pregnancies lasting more than 274 days. So finding the percentage of data items between two given items in a normal distribution, you're going to convert each given data item to a z-score. You're going to use the table to find the percentile corresponding to each z-score in step 1. And then you're going to subtract that percentile from the greater percentile and attach a percent sign. So let's try this for example number 3. The amount of time that self-employed Americans work each week is normally distributed with a mean of 44.6 hours and a standard deviation of 14.4 hours. What percentage of self-employed individuals in the United States work between 37.4 and 80.6 hours per week? So first we need to find the z-score for both of these data items. So the z-score of 37.4, so we take 37.4 and subtract the mean of 44 and then we're going to divide by the standard deviation, which is 14.4 hours. And so on top we end up getting negative 7.2 all over 14.4. And this gives me negative 0.5. And so looking on the table, this gives me 30.85% who work less than 37.4. We want to do the same thing for 80.6. So we take 80.6 and subtract 44.6 and divide by 14.4. This gives me 36 over 14.4. Or we get 2.5. And then on the table, that gives me 99.38% who work less than 80.6 hours a week. And so to figure out how many work between 37.4 and 80.6, we just subtract those two percentages. So 99.38% minus 30.85%. That gives me 68.53% of people work between 37.4 and 80.6 hours a week. And so the table below summarizes the three methods we used in this section. The percentage of data items less than the given data item, you just use the percentile table for the z-score and add a percent sign. To find the ones above the data item, you still need to find the z-score but subtract it from 100 and add a percent sign. And then to find between two items, you find the z-score for both and then subtract it and add a percent sign.